In this session, I will talk about an ideal current source. An ideal current source supplies a constant current I to the external circuit no matter what the resistance of the external circuit. So, whatever be the resistance of the external circuit, the same current comes out of an ideal current source and its internal resistance is infinity. So, the potential difference across an ideal current source is I times R in this case. So, it depends upon the value of R. So, this is I times R. So, as R changes, the potential difference across an ideal current source changes, but the current supply does not change. Now, this is a mathematical idea. Now, physically, I give you a crude example of how to make something close to an ideal current source. Suppose this is point A, this is point B, and they are not connected by any resistance or any conductor. Now, I connect I to a Van de Graaff generator and B to the ground. Now, this Van de Graaff generator is maintained at a voltage is equal to I times R. Now, this A and B are connected to R. So, this IR, as long as there is IR as the potential of the Van de Graaff generator, the current I will flow through this and flow into the ground at the other end. Now, A and B are not connected, so there is an infinite resistance between A and B, and the current also does not change as long as the Van de Graaff generator is maintained at a potential of IR. So, this is a close approximation of the mathematical idea of ideal current source. Now, suppose I have an ideal current source which is capable to supply a current let us say 10 ampere. Now, if I have a resistance equal to 20 ohm, the potential difference across the source is going to be 10 times 20, which is 200 volts. And if I change the resistance to 30 ohms, the potential difference changes to 10 times 30 equal to 300 volts. So, the terminal voltage across an ideal current source can change, but the current will not, and the internal resistance of the source is always infinity. Thanks for watching.